Hey, physical science students, Mr. Lambert once again. This particular screencast is going to focus on what Miss Wood and I have in our Google Classrooms labeled as Lesson 9. It covers Chapter 3 in the textbook, Section 2. It covers pages 80 to 85, and it focuses on Newton's three laws of motion. We hope that this lesson will be a review for most of you, but I am going to focus on Newton's second law. Even though I'll talk about the other two, I want to focus on Newton's second law because it describes an equation, the relationship between force, mass, and acceleration. If you remember in the last screencast, in section 1, we focused on forces and how they're either a push or a pull. And if you have an unbalanced force acting upon an object, it can change its motion in a particular direction, therefore changing its velocity and causing it to accelerate. But here we go. Newton's first law is going to be up on my board. Okay, real quickly, I have written out Newton's first law of motion, which states an object will continue in motion or at rest until acted upon by an unbalanced force. So if an object is in motion, it's going to keep going in that same direction, the same speed, the same velocity, until an unbalanced force is acted upon it, and then it will change its velocity. It'll change its direction. We also call Newton's first law of motion the law of inertia. Notice I have inertia underlined here, and I have a definition. It's in the book. Inertia is the definition is the tendency of an object to resist a change in motion. So basically, in a nutshell, things, objects, they want to move the way they're moving until something else, another force, an unbalanced force, acts upon it. Even if they're not moving, they're going to want to not move until an unbalanced force acts upon it. Next up is Newton's second law. Okay, I have written now Newton's second law of motion. It's basically described by a mathematical equation. The second law of motion states that the force on an object is equal to the mass of the object multiplied by its acceleration. I want to remind all of you that we've described forces in previous videos, and forces are measured in newtons, capital N. I'm going to write that right here, newtons. When you see the mass of an object, that is typically described in, or it's given in units of kilograms, kg. And acceleration, again, from previous videos that we have provided, acceleration is, the unit is meters per second squared. That's the standard unit. So once again, force equals mass times acceleration, or F equals ma. I'm going to pause the video and I'm going to show you how to rearrange this particular equation algebraically, and we can solve a problem or two using Newton's second law of motion. So what I've done here is I've listed the three different ways you can solve for Newton's second law of motion. We teach it as force equals mass times acceleration. If you were solving for force, again, it would be mass times acceleration. You would get those particular measurements, you would multiply the two, and you would get a force, and the unit would be in newtons. I've rearranged it algebraically to solve for mass right here. Mass would equal the force on an object divided by its acceleration. Again, since we're solving for mass in this particular case, right here that I'm circling, this middle section, because it's mass, you would be using units of kilograms in your final answer. And lastly, if you were solving for acceleration, the acceleration on an object, it would be force divided by mass. All of this is a relationship between force, mass, and acceleration. I want you to think about this. If you were kicking a soccer ball, if you kicked the ball really, really hard, the ball would accelerate because you applied a large force if you kicked it hard. A soccer ball doesn't have a whole lot of mass in kilograms, and it would accelerate. But what if you were to try to kick a bowling ball? Let's say you tried to kick a bowling ball really hard. You would apply the same amount of force as you did with the soccer ball, but the bowling ball has quite a bit more mass. If you think about kicking a bowling ball, it is not going to accelerate as much as a soccer ball would, so acceleration would go down. Newton's second law basically describes the relationship between force, mass, and acceleration. Let's do two example problems quickly. Okay, our first example problem for Newton's second law is from page 83 of the textbook, problem number 12. The problem states, what is the net force on a dragster, a fast race car, with a mass of 900 kilograms? Right off the bat, that is a measurement that you want to take note of. Oh, my board's falling. 900 kg. Because that's kilograms, you know that this particular measurement is the object's mass. Mass is measured in standard units of kilograms. So if the dragster has a mass of 900 kilograms, what's the net force if its acceleration is 32.0 meters per second squared west? Once again, notice this meters per second squared, and even the direction, tells us, because of this unit right here, that this is the object's acceleration. We have been given its mass and its acceleration, and we want to know what is the net force. We are solving for force. Keep in mind, forces are measured in newtons. So what I've done here is I've taken the mass, 900 kilograms, multiplied by 32.0 because it is the mass times the acceleration. Here's our acceleration, here's our mass. 900 times 32. I don't even know the answer, and I'm going to do it in front of you right now. 900 times 32.0. You could probably type in 32 on your calculator, and we get an answer of 28,800. Yep, 28,800. But what? We're solving for force. Our answer is going to be in newtons, capital N. So this is a classic example where you're solving for force. I'm going to do one more example problem where we're either going to solve for mass or acceleration. Okay, in this last example problem, we're still using Newton's second law of motion, but we are going to be solving for something other than force. This is on page 83 of the textbook, example problem 2. It's actually above, the problem is above the previous one that I just mentioned. But I condensed the wording of the problem. I want to show you the measurements and how we can solve for it. The problem states you push a 12 kilogram wagon. Stop right there. 12 kg. What is this? That, because you know that that's kilograms, there's your mass. Boom, there's M. You push a 12 kilogram wagon, we have the mass, and they give us this time the net force. The net force is 6, notice the unit, newtons. That's a key, that's a giveaway that is the measurement of force. The net force is 6 newtons to the south. The question is asking us, what is its acceleration? Let's recap real quick. We have mass because kilograms. We have force because newtons. We are solving for acceleration. Notice what I did down here. I rearranged the equation, and you can go back and look at this video because I have all the different ways you can solve for Newton's second law equation. We're solving for A. We're solving for acceleration. Acceleration equals the force divided by the mass. We've been given our force, which is 6. We've been given our mass, which is 12. A equals 6 divided by 12. And that And you can use your calculator if you want, but 6 over 12, most of you can probably simplify that. Our acceleration is going to be 0.5, or you could say 0.5. But 0.5 what? Keep in mind, we're solving for acceleration, and the standard unit for acceleration that you're going to see most of the time is written in meters per second squared, and that is Newton's second law of motion. I'm going to pause real quick and talk about Newton's third law. Okay, Newton's third law of motion is on page 84 of your text. It simply states that when a force is acted upon or exerted upon an object, a second force will also be exerted on that same object. Forces come in pairs. If I were to exert a force with my top hand on my bottom hand, not only would I be exerting a force from my top hand, but that bottom hand would also be exerting the same force on that top hand. So if you have any other questions, make sure to contact Miss Wood or myself. Those are Newton's three laws of motion.